Hey guys, and welcome to this video. Today I will talk about forward hooks in PyTorch and how you can use them to visualize activations of your neural network. So what exactly are these forward hooks? Well, said shortly, they're just functions that get called right after you do your forward pass. Okay, and I decided to show you where exactly in the source code they're implemented because I find the source code really readable and very instructive. All right, before I do so though, let me just pin the version of Torch to a specific version, let's say 1.7, so that if you're watching this far away in the future, you can see exactly the same source code. And the module I'm after here is called module.py. It's here, the full path is here, and what this module actually contains is the building blocks of PyTorch, let's say. If I open it, what I'm after here is the class called module. Here it is. And you've probably seen this class before because it is the way how you define your custom layers in Torch, and also all the existing layers are subclassing from it. And I actually find the small example that they're providing here really nice. So let me quickly explain how one defines a custom layer in Torch. So you first need to subclass from the parent, and then you need to define two methods. One is the constructor, the dunder init, and the other one is the forward method. So in the constructor, you're supposed to first call the constructor of the parent, okay, and then you're supposed to define all your layers that you're planning to use in your forward pass, as well as any learnable parameters. And then the second method, forward, represents the forward pass, where you define how you go from the input to the output, okay? The thing that's really interesting is this call to the parent's constructor. I actually have the constructor right here. And as you can see, there's a lot of initialization going on. And the attribute that we're interested in, not surprisingly, is called forward hooks underscore forward hooks. And this is where PyTorch stores all of our forward hooks, okay? So just keep it in mind, and let me go back to the example and point out like one important thing. And that is that whenever you are using this neural network, you're not supposed to call the forward method directly, and instead you're supposed to use the dunder call method, or just call the class. And the reason for that is the following. If I go to the implementation of call, you can see that it actually calls the forward method inside of itself. And on top of that, it has a lot of other functionality. And this functionality is related to all kinds of different hooks that PyTorch has. But what we're interested in this video is the block of code right here that gets executed right after the forward method. And it represents the calling of the forward hooks, okay? So what it does is that it iterates one by one through our forward hooks that we have registered, and it then calls them. And what's really important is that you can see that it has three parameters. One is the self, which is the module itself, then it's the input, and then it's the result of the forward pass, okay, here. What's really important is that if it's actually not none, we redefine the previous result with whatever the hook outputted, right? So I would imagine that you probably have already many ideas how you could use this, because this hook framework is really powerful. But what I want to talk about in this video is how we can use it to visualize activations. But before I do so, let me just probably point out two other applications that I've seen before. First of them is definitely using forward hooks for debugging purposes, because you can do a lot of printing and logging inside of your function here. And the second application that I've seen is on purpose modifying your output tensor or whatever the output of the forward method is, right? Anyway, we are focused on visualizing of activations. And I think that's it for the theory. Now I would like to show you a very short example of how one can use the forward hooks in action. Let's get started. Let me create the script and let me do some imports. So I will import torch, then I will import functional. And lastly, let me import two modules. One would be linear layer, and then the parent module class. So here, linear and module. And now we're ready to define our custom network. So as discussed, we need to subclass parent, and then we need to define two methods, the constructor and the forward. So let's do that. Let's call our network and subclass from the parent, and let's start with the constructor. The only argument there is the instance of self. And first of all, we need to call the constructor of the parent. So something like this should work. And then let me just define a couple of linear layers. Let's say like this, 3 of them. So here rather 2, and here I will get 3, perfect. And let me just make sure that the dimensions are matching. So here 20, here I will put it equal to 30. Of course, here I also need to put it equal to 30. And at the end, let's say our output size is going to be 2 for no specific reason. And the second method I would need to define is the forward method. This one takes in the self instance and also the input tensor. And here, I guess not surprisingly, I will just do something like this for all of the linear layers that I defined. So here, cool. And to make things a little bit more interesting, let me also run the output through a rel activation. So something like this should work. Cool. So now, if I didn't make a mistake, we should have a valid neural network, a multi-layer perceptron. And like one way to test this is to just generate a random tensor and run it through the network. So let me do that. Let me turn this into a legit Python script. If name equals main, and here let me generate the tensor. So we use torch random. To simplify things, I will just set the batch size equal to 1, which means there's only one sample in my batch. And then here I need to match the first linear layer, the input features. And let me instantiate the network. It's nothing else than this. And then to actually run the forward pass, we use the call method rather than the forward method that we implemented, and we should get our predictions. All right, so let's just print this out. So let's format this, and here in the second window, I'm in the same folder. Let's just see whether it works. Saved it, but I should be getting, 2 outputs. What's interesting also is that, as you can see, the result is different each time, and the reason for that is actually here, because each time the input features look differently, and also the fact that we reinstantiate the neural network, and also the weights of the linear layers are initialized differently each time. All right, so we have a working neural network, and let's continue. So now the goal is to visualize activations of my linear layers. I will use TensorBoard to do that, and a solution that doesn't use forward hooks is just simply calling the logger manually each time you want to lock a specific tensor and create a histogram of values. So let me show that to you. Let me start by doing some additional imports. Okay, and here we import a summary writer, which is the actual class that is doing the logging. Okay, and let me just instantiate the summary writer, and what it expects as the only parameter is the path of the folder where you want to have the logs. So let me create this variable. And let's call it tensor board logs. All right, good enough. Self writer, summary writer logger. Perfect. So we have an instance of the writer that we can access as an attribute. And here, after the first linear layer, we can simply use the method add histogram. Let's say we will call this value 1, and we provide the tensor. And what we want to do, we want to copy paste this to all the places where we want to lock the tensor. So after each of the linear layers. Cool. And now we should be ready to run this. So let's see what happens. This has been seen before. However, what also happened in the background is that the tensor board logs folder got created. And to visualize, to launch the TensorBoard UI, you just use the TensorBoard executable, and you provide the path to your logs folder via the logger option. So it's this one. And we can see right away that it proposes a localhost URL. And if we go to histograms, we right away see that all of the 3 tensors got locked correctly, and we see their corresponding histograms. Okay, so this definitely works, but as you would imagine, it's by far not the optimal approach. So the main reason why this solution is not that great is because of the forward method and how it looks like. So first of all, one right away sees that we call the add histogram method 3 times, which is very redundant, and one should probably refactor it. And second of all, forward method should arguably only contain code related to the forward pass, and any debugging, visualization, or logging functionality can be there. However, chances are it's only going to be temporary, and it's very likely that you don't want to keep it there if you deploy the model in production. So a solution that addresses both of these problems is using forward hooks. Let me just quickly delete what we did here, and at the bottom of this page, let me define a function that I will call activation hook. It's going to have 3 arguments, and I will describe them. Okay. So first of all, we need to provide the instance of the layer that we want to attach the hook to. So this is in general going to be a torch and a module. The layer we right. The second parameter is going to be the input tensor. So that's the same input tensor that goes to the forward method. In our case, it's going to be a torch tensor. And it's just the input to the forward method. And lastly, the third argument is going to again be a torch tensor, and it's going to be the output of the forward method. Okay. And in theory, we can also return a modified version of this output, but we don't need this. We only want to, use this forward hook for logging purposes. So there is no need to modify it. First of all, let me just make sure that we are here, that we can see then the standard output. And then we want to replicate the functionality of the previous example. And to do that, let me just move the instantiation of the writer to here, which is going to work okay in our example. Let me remove the self here. And as we did before, we simply take the writer and we add histogram. Now, what do we want to use as a name? Well, I suggest we can just use the representation of that layer, because Torch provides really nice representations of its layers. So I would use that. And then we want to provide the actual output of the forward. Okay, and at this point we more or less replicated the above functionality. The only thing that is left is to somehow tell Torch to use this function as a forward hook. And for exactly that purpose, there is the register forward hook method. So we take our network, we take the layer we want to attach the hook to, and then we run register forward hook, and we give it the activation hook. Perfect. We can just do this same thing for all three of the layers. And the last thing here is that we need to move the actual forward pass on the entire network. And the reason for that is that here we instantiate the network, and at this point it has no hooks assigned to it. And here we actually assign the hooks to it, and here it's going to contain it. So when we run the forward pass, it's already going to be active. Whereas if we kept it here, it would still have no hooks attached to it. Okay. So let me put it here, and let's try to run this and see whether it works. Yeah, let me maybe remove the TensorBoard logging directory. And let me run the source code. Cool. So you see that the here was printed out 3 times, and that we again got the 2-element tensor as an output. And now we want to check TensorBoard, same as we did before. Going to histograms, and as we can see here, we again have 3 different histograms, all representing the 3 linear layers. Here the representation is different. Before we used just numbers. Now we have like a full-blown representation string of that layer. Okay, so we managed to reproduce the functionality that we had before with forward hooks, which was the goal. And arguably the solution is way cleaner, and I have used it a lot of times. Before I finish this video though, let me just note one more thing. And that is, you probably wonder, well, what if I also want to dynamically remove a hook? Because now, whenever you call the network, the hooks are going to be active. But what if you want to dynamically choose when the hook is active, when it's not? Is there a way how to deregister the hook? And the answer is yes. So what you need to do here, you just need to somehow put or cache the return value of the register forward hook into a variable, which would be a handle for that hook. And what you want to do if you want to deregister the hook, you just use it and call the remove method, okay? And to illustrate that it works, let me call the forward pass, or let me do the forward pass one more time afterwards. Maybe I can remove this at this point because it's useless. So here, all 3 of the hooks should be active. However, here, only 2 of them should be active. If we did this right. So let's see. Yeah, exactly. So these 3 are coming from the first call to the network, and then the last 2 are coming from the second one. All right. Hopefully this video was helpful, and I will see you next time.